Okay, so today is going to be training on the OpenStack Cloud and the Juno version. So today's session is going to cover most talking about the agenda of this training. For the module 1 is going to be the virtualization and who is actually using virtualization and the types of virtualization. You might know about different virtualization models and to the next shift of the cloud computing, what is the attributes of cloud and subtypes of cloud. This is going to be the, the agenda for module 1. To start with, what is the IT pain points in which is in the traditional IT pain points? So this is actually I am trying to differentiate between the different evolution of IT infrastructure, and the service management. So what is a traditional thing is the inefficiency and the downtime, which all the infrastructure which we having uh, downtime of for the production machines is the business is growing and nowadays nobody wants a downtime for their infrastructure, and there is an inefficiency and spending a lot of money, uh, putting a lot of resources and putting a lot of servers and not using as efficient as possible in many of the organizations. That is what the traditional IT pain points, and most of the CTOs, and they have a concern saying that, hey, you're paying a lot of money, but we are not going to getting anything out of that, and we are not growing as a business. There are a lot of challenges, and still we are paying a lot of money. So that's what the traditional IT pain points which I am mentioning here. So what are the new pain points? Well, I have majorly 2 points. One is the inflexibility and the other is a fear of lock-in. So inflexibility meaning from an evolution from a traditional data center from a physical environment, dedicated environment, to a virtualization environment, the inflexibility and to cope up with the application, which is legacy apps. And some of the things works on the virtualization, some may not work on the virtualization, and maybe some I will go deep into this for the next slides. So that's what the flexibility and the fear of lock-in. So once they are locked into one of the technology vendors, they're not able to move to any other providers. There are a lot of other challenges incorporated with it. So that's what the new IT pain point. So basically, as a business, for an organization, it is actually a pain point from an IT's perspective, right? So it means different to different people, and from the executive of the company, he may feel like, right, we can't move into any other platform, right? Because our platform is not giving as much flexibility uh, to move an app to an application to other platform, because they have a lot of money invested in the first um, shift of IT evolution. So that is some of the examples. So I will cover more deeper on this. Okay, so this virtualization, that's what from the traditional around 2010 and before that. So there is a technique called virtualization. As a revolution happened in x86 server machines, which actually partitions the physical servers into a number of virtual servers with the help of a software layer that is nothing but an abstraction layer that abstract the hardware and make it more easy to manage the machines or to efficiently use the physical server resources. That is what, and more about the virtualization, and there are another way of looking at is having a multiple operating system on a single physical system, and which shares the underlying hardware resources. So basically shares the compute and storage and the networking capabilities of a physical servers, and abstracting it to the next layer, having a bunch of servers and a virtual servers in the same platform, right? So if you look at the diagram, which is from the, of course, from the VMware terminologies. It's gone to the traditional architecture, and you can see the physical box. There is nothing but it can be any x86 platform hardware, and on top of that is an operating system, and top of that is an application which is running. And most of the traditional architecture in that application, say for instance I have an Apache web server which is running on a physical box, right? Uh, from the traditional architecture, that application is not consuming the full resource of an app of the physical resources. So they are actually wasting a lot of money there, and they are investing. And if a new application needs for a business, they are provisioning there. They want to go into the same process of procurement of new hardware and installing the operating system. There are licensing costs involved, and of course they want to build the applications on top of this operating system. That's what traditional. So the value the virtualized environment brings to the whole IT evolution is, as I said, there is an abstraction layer that is for a VMware. It's VMware EXX Hypervisor, and this acts as a software as an abstraction layer, and it will act as an sandwich session between these applications which is running on top of the hardware, and is talk to the physical machines in the shared underlying hardware resources. Okay, so what are the benefits of virtualization? Cool. Yeah, that's a good question. So I will cover in the next slides about the Zen. What do you mean by that hypervisor, Zen, and KVM and stuff like that, right? For now, so I will complete this virtualization benefit. So it's basically server consolidation and reduce the capex model and the operational expenditure for an IT. That is the main benefits of virtualization, and the other main the points are the redundancy. So basically we have redundancy provide about the infrastructure layer, and we can build a resilient architecture in a VMware or any other proprietary stacks vendors who is providing virtualization. So, and of course it improves due to the real-time resource scheduling, and there are a lot of other technologies which is used for the virtualization abstraction layer. There are other performance bottlenecks when we use the fully virtualized and this virtualization mode. So this is the second, and the other virtualization mode is a para-virtualization. And in this virtualization, a portion of the system resource and a partial amount is abstracted. That meaning the guest operating system which is running on top of these physical machines on top of the virtualization layer is aware about that it's running in a virtualized platform. So it basically gives a better performance, and I will cover about the types of hypervisor in the next few slides. So then you will.
When you say part system resources or a partial amount is expected, is that
right.
Hardware you are saying, or operating system you are saying? What is that?
My meaning the system resource, I mean here is a physical resources. So obviously the physical resource has to be abstracted. That is what the virtualization brings into the to the IT, and the abstraction means it's just a portion of the system resources. When I say system resources, it can be a computer, it can be a network, or it can be a storage of a server. So is that clear?
Yeah, okay.
All right. So basically an guest operating system which is running, I will go back to the same slide. If you look at the VMware architecture on the right, you can see that app and operating system which is there are 6 apps, 6 guest operating system which is running on the VMware ESX. And what it means to the para-virtualization is this virtual machine is aware that it's running on a virtualized platform using the drivers, because the drivers which is included in the operating system is aware about that, right? So So that's what I mentioned is a guest operating system is aware of running a virtualized platform and it's give better performance. All right. Right. Okay. So this is what it is. I'm giving deep dive into the hypervisor layers, the types of hypervisor. So on the left, I will start from the left, and you can see it's a normal server. It's a single operating system that direct access to underlying hardware. That is as per the traditional dedicated server. When it's a dedicated server, there are a lot of vendors like HP, Dell, IBM. There are a lot of blade servers and all. So that's what it means. So it's a physical box. There is on top of that, we will install a Windows 2008 R2 or Linux RHEL or CentOS machines, which will be running on top of the normal server. That is there is no abstraction. So these physical resources talk to the operating system directly. There is no layer in between. So coming to the types of hypervisors, there are two type 2 hypervisors. That is some people call it the hosted hypervisor, and the other is type 1 hypervisor or bare metal hypervisor. Good. So in type 2 hypervisor is something which we do basically you can see as an VMware workstation, which you will install a VMware workstation exe on top of your Windows operating system if you have a laptop and running different physical guest machines on top of it for doing testing. But it doesn't mean that you get the enterprise grade security and performance features, and that is obviously a drawback for this kind of type 2 hypervisor. So you're not getting the better performance, and end of the day you will be running 2-3 virtual machines, and is only meant for the testing beds if you want to test some machines on top of that, right? So that's what is the type 2 hypervisor. So on the diagram you can see an hardware layer, and top of that an OS layer, which can be it will be Windows. So nowadays people install Ubuntu operating system or a CentOS or Red Hat operating system enterprise, and on top of that they will install VirtualBox. I think you might have familiar with VirtualBox.
Yeah.
Right. So this is one of the examples. So another is a VMware workstation, and the other is a VirtualBox that runs on top of the Windows or the Linux, and uh, VirtualBox have the EXEs as well as the Linux versions of it. So on top of that is you can run guest machines or VMware workstation, right? So our main topic is going to be the type 1 hypervisor and the bare metal. That is where the VMware EXXi hypervisor, and you, of course, you have mentioned the Zen server hypervisor, uh, which is actually some people call it a bare metal hypervisor. That means it is installed on the bare metal physical server machines, and it obviously acts as an abstraction layer, and we can run as many as guest operating system, depends on the physical capacity which a physical box has. So obviously we'll get a bare metal performance in this type of hypervisor. Okay, so to this is what, yeah, right here you can see, and I'm just trying to explain it here the same whatever we have explained the last slides, just type 1 hypervisor and type 2 hypervisor. As I said, what you the para virtualization driver and tools, that is going to be there are certain tools and the drivers which is related, which is running on a VMware based or the Zen based or a Microsoft Hyper-V based hypervisor. So obviously, so the second, that type 1, and type 2 is going to be it can be the workstation or it can be the VirtualBox, and it will be like adding in another layer of hypervisor on top of a host operating system, right?
So what is the difference? Because even here we have a para virtualization, a driver and tools,
right?
And here it is managed by the hosted hypervisor, But
Exactly.
here we have a host operating system which is managing the hypervisor, right?
Yeah, that is a
What's
good
the
question.
overhead?
So
What is the
there
overhead?
is overhead is like there are different layers because it goes to the hypervisor layer and is masked the host operating system layer. So that is the reason I mentioned here is that there is a performance trade-off for the type 2 hypervisor, right? So obviously it will be like the performance is a main impact.
What kind of performance can you explain? Because I'm just wondering because in a type 1 hypervisor, your
Right.
VM knows what is
Hmm.
your hardware is, correct?
Exactly. Right.
So then it's going to directly communicate with the corresponding hardware. So the host need not do any overhead or work should be there, correct?
Right. So
Because
in the
but
type,
type 2 hypervisor, host himself managing the guest IO or guest resource management. So host is overloaded in type 2.
guess is overloaded. That's what I mean to say. So that is the reason there is a performance impact because there will be like two layers. One is a host operating system layer. It can be a Windows or Linux, as I said, and top of that we are installing this software, right?
So you mean to say you are saying type 1 is better or type 2 is better?
Type 1 is better. Obviously type 1 is better. There's no doubt in that. So that is the reason like if you might have used VirtualBox, there are a lot of other challenges which is related to having that is the reason nobody is using that is a production grade, right? So there is a lot of overhead in that because there are different layers of we are installing on the host operating system. On top of that host operating system we are installing a VMware workstation or is it VirtualBox.
Okay, okay.
And
One second. So that is type 1, am I correct?
no, I am talking about type 2. Don't confuse. Forgot about the para-virtualization drivers and tools, right, for a moment. And think about a physical hardware. On top of that, we are installing a software which actually do the abstraction and which
Mhm.
can actually capable of doing the performance for a guest operating system which is running on a physical box. What it meaning is like I'm meaning is a type 1 hypervisor and these VMs have the capability of say for instance it's getting it means that it's running on a it understands it's a virtualization environment and it gives a better performance and it's talked to the physical hardware through this abstraction layer only, this hypervisor, the software abstraction layer. But in the case of type 2 hypervisor, there are two layers of overhead. One is a host operating system and another is the hypervisor layer. And right, so that is the reason I want to, I am stressing about the performance, right? Because it goes to the different layers of the software abstraction and it's not going directly to the physical hardware which the host operating system understand, hey, this is running on the VMware or the VM and I'm getting the right performance. It can be like we can consider as an host IO or the network read IO or write IO, which is another topic which is need to be battle of. Yeah.
Okay. So can you go back to the previous slide? I want to
This
get
one
clarified one thing. Previous one. Yeah, hold on.
again, this one or the other one?
Yeah, this one.
All right. Yeah, you can see that type 2 hypervisor, which I have mentioned is a server that host OS has access to hypervisor layers. Obviously, that type 2 is not meant for production grade.
Okay.
Is that clear?
Okay. Yeah.
All right, so I think why you confuse is that first I mentioned type 2 hypervisor in this slide and here I mentioned
Yeah.
type 1 hypervisor. That could
The
be that.
order.
All right, so okay, so who are the server virtualization vendors? Major server virtualization vendors like VMware ESXi and Citrix Zen servers and Microsoft Hyper-V and Red Hat RHEV. So these are the four virtualization vendors. I hope you you already mentioned you're familiar with the Citrix Zen or you're familiar with the open source Zen.
Citrix.
Citrix. All right. Okay. Cool. Okay, so I think I can go to the next slide. So you are familiar with this for hypervisor. At least you have some working knowledge in the Citrix and hypervisor, Citrix and server,
Yep.
right?
Mhm.
So I'm going with what is the common use case and the business drivers for virtualization, right? So these are some of the use cases which drives a business user to take a decision whether it's they need a paradigm shift from an uh, traditional IT to a virtualization roadmap. This is one of the main reasons. One is major and foremost thing is a server and infrastructure consolidation. So basically the infrastructure virtualization helps to consolidate and to reduce, as I already mentioned, that it reduces data center footprints and easy to, and second thing is on the infrastructure management. We can manage uh, the, the the VMs or the associated parameters related to the for managing an IT perspective. It's become easy, simpler for them infrastructure management. So these common use case I have put up not only based on vendor like VMware or anything. So I have put it as a general. So it may differ from different virtualization vendor, right? So and uh, the other thing is on the disaster recovery and continuous operation. So I hope you know about disaster recovery in some form. So hope or
Yep.
do you need some uh, input on that? So are you a part of a BCP planning for your organization or for your customer by any
Yes.
chance?
Yeah. We do often business content disaster DR plan. So I'm aware of it.
Okay, that is cool. That is good to know about. So that is the main driver for this virtualization. So to go into deep dive, since you know that what is going to be disaster recovery and the business continuity planning is like in a VMware, there are a lot of replications which is rolled by it can be from the VM replication to multiple sites, or from a storage perspective, as in a storage vendor like EMC or NetApp, it supports the storage replication from one data center, physical data center to another physical data center. So those are the, and it makes simple for as an admin or for an technical lead who to lead these projects and do this kind of a BCP plan, and it makes business very very robust and very reliable thing from a business point of view. So that is the reason. So otherwise there are a lot of pain points which is associated with the traditional IT dedicated servers or BCP plan. So that is one of the major things. DR and obviously the strategy to unify the IT infrastructure, that is an initiative from the business users, uh, business from the company, and obviously their CFO of the company uh, asks a lot of questions on cost optimization. How, hey, I'm this technical person say in a company, say, hey, we want to go with the VMware, or we want to go with the Citrix and hypervisor. So what's the uh, what is the what it brings to the cost? So it brings down to the cost and it improves the efficiency. And so here again, there is a simple term we can say is a cost optimization can be done using this virtualization, right? Of course, and the other major foremost thing is business agility. So how is a business
But
agile? So
yeah, but you said there's a lot of VMware options. I mean, not VMware, virtualization option.
right,
Virtualization option available, correct?
right.
Which one do you choose on base of what? We have VMware, we have now Amazon, we have
Uh,
OpenStack.
Not really. So I'm not going to the OpenStack or the Amazon. So that is more about the cloud part. So I'm talking only about the business drivers and common use case for virtualization. So I'm talking about only the server virtualization. So you can compare, as I mentioned, the VMware EXXi, why VMware EXXi, why Citrix-Zen, why Microsoft Hyper-V, why Red Hat RHEV. That makes sense. So does it make sense?
Okay, so basically you mean to say go for virtualization.
No, I haven't covered the cloud part yet. So I'm still in the virtualization journey.
Yep,
Right.
okay.
As an enterprise, I am still in the virtualize and still in the traditional IT. I have a lot of pain points associated with the traditional IT, and my CFO and CIO says, hey, what says to the IT crowd or the IT technology specialist, uh, chief information officer, hey, what is going on with IT? This business is growing like anything, and you're not providing the infrastructure whenever it is needed. So that is one of the simple use case. And say for instance, I have a company, an enterprise, I have a 10 products, right? They are launching a 11th product and they want to bring live servers and they want to be in the time to market or to be live in another 1 month. I'm saying one example. This may not be relevant for some of the consumer. I'm saying to understand better. So for them, what it means is obviously in a traditional way they have to procure physical servers, they have to procure the storage, and they have to procure the network devices, and obviously it increases the data center footprint, and obviously it doesn't meet the business the agility which I have mentioned. So obviously it will take procurement will not happen in 1 week or so. It will take some time, and which hardware to decide and a lot of other stuff related to that. So am I right in, so you got where I am coming from, right? So do you have any
Okay, got
questions on that?
it. Okay, yeah, I'm okay.
Right. So I'm just trying to explain you more from a business perspective as well. So from a technology perspective, you're right. So there are a lot of other vendors. Why you want to choose VMware EXX? There you ask a lot of questions like you ask. Obviously, Amazon is not a player in the virtualization. That is a different story. And uh, why choose Microsoft Hyper-V? That depends upon different factors, what they want to achieve, what they want to, obviously they provide the resilient or the redundancy for the infrastructure as well as from the BCP requirements. That makes different for different people. So that's all about it. So cost optimization and the business agility, you have to be faster time to market. As I said, new product arrives and it has to be happens within 1 or 2 days. Hey, then the business people, hey, wow, um, I am live. I'm actually launching my product in 1 or 2 days than my competitor. So it makes a business more values. Am I right? So that is the kind of uh, value which is bringing into the virtualization. So hope that is clear about what I mentioned about business agility and cost optimization in some form.
Yep, yeah, thanks.
All right. Okay. So and other foremost thing in is a stepping stone to the green IT and the cloud computing evolution. So that is one of the another common driver on use cases. So who want to go into the cloud? So want to go into the virtualization journey, and some of them, some apps doesn't support virtualization, so still it's going to the legacy applications that I will cover it later. So this is all about the virtualization. I hope this is clear, right? This topic is clear, and I will go to the next topic that is more about the where you mentioned about the cloud and the OpenStack of the world. Oh, that is cloud computing. So what does it mean? So yeah, in a simple term, it's a collection of technologies, and it's abstract, the provisioning and the management of compute hardware. So what it does is virtualization brings a benefit of having abstracted and the pool of the resources which the customer brings, like the compute and the storage and the networks of the world, so which I've already mentioned. So it automates and orchestrates the cloud computing. What it is, it automates the task which is doing for the polling stuff. It automates and orchestrates in a better way, and the other main advantage of the cloud computing is a utility service giving access to the technology resource available on demand. What does that mean? So utility service is an on-demand, right? We are paying only for the service. If I am using a two virtual CPU or two virtual RAM, I'm paying only for that service. I'm not paying only for the not for the whole hardware which their virtual machine is running, right? So that is the kind of accessibility and efficiency which cloud computing gives, and the utility-based billing as well, right? So I'll cover more about the different categories and in the next slide. So this part I will kind of cover the benefits. So obviously it lowers the cost. How it lowers the cost? It means that it for a different business unit, uh, for a business it will be like a utility-based billing, and uh, that the compute is on compute or the storage on the network, whatever they want to provision, it's on demand. On demand they can provision these machines, right? So it makes faster time to market, as I mentioned already. So it's like for a business case, where it makes easy for a business user to take, hey, I can provision a machine within 1 or 2 days, which virtualization brings. Using cloud, I can provision a machine within 20 minutes time, and I can provision the applications. I can do a test bed, and I can do, once the testing is done, I can go into the production. So that what it brings to the business is they can focus on the business, they can focus on their core business, they can uh, they are actually getting the overhead it's used given to some of the service provider who is managing the infrastructure for the cloud infrastructure, and there are um, basically what business needed, they want to concentrate on their business, and they will outsource some of the stuff that I will come into the later part. So I'm just giving as an overall benefit of cloud, and obviously the capacity capital efficiency which cloud computing brings to the pooling and automation which it brings to the market, right? So here is the main thing, so the attributes of cloud. So I have these terminology which I already mentioned: resource pooling, scalable, and so what it means is everything has to be on as a service model, wherein it has to be on service based, and it's well defined. Every service would have a well defined service interface. So service interface meaning it can have like a web service which can talk to the other third-party providers using APIs. That will come more into the OpenStack stuff. So I'm not going deep dive into this at this stage. And the other thing is on the shared services shares a pool of resources to 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 build economics of scale, right? So that is a kind of that's one of the attributes of cloud, and obviously the scalability and elasticity which cloud brings. Um, the scalability, when I'm meaning, I would rather explain more about scalability. What it means to scalability. I forgot to mention in the scalability in the virtualization. Virtualization is scalable, and for a virtualization, what the virtualization brings is we can scale up an application. So for instance, I have an application which is running two virtual CPU and two virtual CPU and virtual RAM, and I want to increase the capacity. I am running out of resource. My application use 100% or 80% of the utilization, so I want to increase it. The only way in a virtualized environment is increasing into two virtual CPU to four virtual CPU if it is a CPU optimized or compute optimized instant application on increase the RAM. So basically is we stop the machines and increase the size of the virtual machine and start the service. So that is what the virtualization brings in. But cloud, what it means is we can have a scale out architecture. When I say scale out, it can be like we can have a multiple web servers. We don't have to do a scale up actually. Instead of that, we can have a horizontal scaling of applications. So you basically add up multiple nodes and of on an application, and you are basically avoiding a single point of failure for that instance or the machines which is running in the cloud. So I will go deep into that later. So I just want to understand that. So any questions? Okay, and of course the other things are the meter by use, and the services are tracked with the usage metrics to enable multiple payment models, because what it means, the cloud is a major advantage that you mentioned is a utility-based billing, and is talk to the different payment model which is in the back end, and it has a good integration, and which will say that, hey, I have a for a corporate company, I have testing team and development team and a production team. Hey, testing team uses my testing unit, business unit uses this kind of uses $1,000 per month. They are utilizing these resources. The company IT says, hey, the production they are using these $2,000 per month. They spawn over 10 cloud machines. So these are kind of they can having accountability of who is using what, and it can be metered by use. That is mean to the cloud, and obviously the internet uses internet technologies. It means is the services which I have mentioned are in different formats and protocols, such as the URLs or HTTP and a web service. It says is an on a state transfer web-oriented architecture. So it's basically every service will have a, as I said, an API, so it can talk to and it can integrate to multiple components and multiple third-party tools. This is all about the attributes of cloud. So this is one of the cloud definition from NIST, and various deployment models and service models, which obviously I will cover in the next couple of slides. And I have to stress upon the essential characteristics as measured service, rapid elasticity, on-demand, broad network access, and resource pooling. It's the characteristics of cloud. So cool, right? So that's all about module 1. So hope I have thrown some light into virtualization and cloud attributes and what is the cloud computing.